Boolean algebra is used to model the circuits in electronic devices, in computers, for instance. So each circuit can be designed using the properties that we have seen of the Boolean algebras, the simplification rules, etc. The basic elements of circuits are called gates, and each type of gate implements one Boolean operation. So, for instance, we have the inverter, that what it does is to implement the complement, or the not, the Boolean negation. Then we have the OR gate, that what it does is just the join operator. We can say the Boolean addition, or the join, or the OR, or the union, thinking in set theory. Then the AND gate, so that this is just the Boolean product, or we can say also the mid operation, or also the intersection, or also the AND, the logic AND. Well, by just using these three basic gates, we can construct any circuit, and any circuit is going to be called a combinational circuit. This is an example of a simple combinational circuit where we use these symbols. We can see here that the X goes to this gate, that is a negation gate and a not gate, and so the output goes to this gate, that is an OR gate, and the Y do the negation and so goes to this gate too. So we can see step by step in a circuit what are the inputs and the output. So for instance, in this part we have that the X is the input, and once that passes through this NOT door becomes X complement, and the Y, once that it passes through this door, becomes Y complement. So these are the two things, X complement and Y complement, that are going to enter in this other gate. And so when they pass through the gate OR, then becomes X complement plus Y complement, where the plus, the addition, is the Boolean addition. Let's see a more complicated circuit here. Let's observe also these notations. These fill dots here are going to mean a branching in the system. Sometimes just because of the way that we write it, we need to specify when the variable, this variable goes here, but this variable also goes here, and this variable goes here. These other dots here and fill, these are different, so this dot means the NOT gates. So this gate originally was an AND gate, but have a NOT, so this is called an AND gate. What it means is that the inputs are going to enter in the AND door, and by having this NOT here, we are going to do a complement of them before they get to be an output. So, for instance, in this case, the first X goes here, the Y and the Z, so we see that here enter X, Y, and Z. And so as an output here, we are going to have X intersection Y intersection Z, right? Because this is an AND door. We can say X and Y and Z. But because of this negation here, we are going to have this output. So this is the output then from the first gate. Let's look at the second gate now. So here we have that this X was the one that came here, and this Z is the one that came here. So the output is going to be here X plus Z, because this is an OR gate. We can say X or Z. And the third gate, this is going to be, we have a Y coming here and an X coming here. And so observe that also we have in this one a NOT here. So then we are going to have X or Y complement, right? Plus because it's an OR, and complement because it's a NOT. And so finally, these three things are the input of this gate. And so the output is going to be this times this times this, because it's an AND door, which is exactly what is written here. So in that way, just looking at the drawing of the diagram, you can find out what is actually what this circuit is doing. For instance, if we have this other circuit here with more gates in here, so you can find out. Stop for a moment now and see if you can find out what is the expression of this Boolean function, what is this circuit doing. Be sure that you write down, when after each gate, it's useful to write here after the gate what is the actual output from that gate, because that will be the input of the next gate. So think for a moment of this circuit and see if you can find the expression. So knowing now what each of the gates is doing, we can design a circuit that does any particular thing, because remember, when we have seen Boolean functions before, we know how to construct a Boolean function that does some particular thing. So then we are going to use that skill to actually construct circuits that perform particular tasks. So for instance, let's imagine that we have this problem. A light fixture is controlled by two switches. So we have to design a circuit so that flipping any one of the switches turns the light on when it is off and turns the light off when it is on. Let's suppose, for instance, that this light fixture is in a staircase. So you would like to have a switch at the bottom of the stairs and another switch at the top of the stairs. So for instance, if you are at the bottom and want to go up, so you would like to turn the light on, but when you arrive to upstairs, you want to turn the light off with the upstairs switch, let's say. But once that you are there, maybe you want to go down, so you would like with that same switch to turn the light on, and so on. So the switches are what is going to be our input, our variables. For instance, let's say that this is the switch that we have downstairs. Well, that switch have two possible values that can take, right? Can be up or down. So can take the values 1 and 0. Let's say that 1 is when it's up or 0 when it's down. So this is then, this x is then a Boolean variable because can take just two possible values. But this other switch also have two possible positions, right, up and down. Let's say that these positions are also going to be 1 and 0, when 1 when it's up and 0 when it's down. So this is also a Boolean variable. So we have here x, which is the switch downstairs. That is a Boolean variable that can take values 1 or 0. And the other switch that is upstairs, that one is also a Boolean variable and can take the values 1 and 0 when it's up or down. But then let's think in the output, the expression of the function. So the output can be that the light is on or off, right? So that we have that the function actually take also two values, different, right? So in different situations, but also take two values. Let's say that is the value 1 when it's on and the value 0 when it's off. So this is exactly what a Boolean function is, right? So this will be a function that takes two variables, x and y, and each variable is Boolean, can take the values 0 and 1. And the result is also Boolean because can take values 0 and 1, also to be off or on the light. But what do we want exactly this circuit to do? Let's arbitrarily decide that the light will be on, for instance, when the two switches are up. So, taking this choice, what are we saying? That when x is 1, I mean when the first switch is up, and when the second switch is also up, what do we want? We want the function to be 1 because we want the light to be on. So, in this sentence here, we are saying that when the switch downstairs is up and the switch upstairs is also up, the light is on. What else do we want? Well, if the one downstairs is still up, but the other one is switched down, so then we want that the light becomes off. Okay, and if instead of switching this one, we have switched the other one, but this one still is up, so we also would have liked that the light is off that. But if we leave this one as it is and we switch the other one down, so then we want now the light to be on. So these conditions is what will make the circuit to do exactly what we want it to do. And now, how do we actually implement this? Well, we know how to write a Boolean function with these characteristics. Putting this data in a table, we are saying that when x is 1 and y is 1, we want the result to be 1. When 1, 0, we want 0. When 0, 1, we want 0. And in 0, 0, we want 1. So this is just another way to write exactly this data. What matters here is that we know when we want the function to be 1. Remember that this is the relevant part to write our expression. So we want a function that is 1 when x and y are 1. So that will give us the first minterm. So it's going to be x, y. But we want also our function to be 1 when x is 0 and y is 0. So that means that we have to add the minterm complement of y and complement of x. So now we want these two things to be the function to be 1 with any of these two things happen. So we know that we have to put here the Boolean addition. And this is the expression then of a function that does exactly what we wanted. So now we just need to implement this as a circuit, but that part is easy, right? So this expression is really very easy to implement as a circuit. We know the x and y with an AND gate. So we put x and we put y and we put here an AND gate. And we want also the complements, so we made the complement of x and we made the complement of y, and we can also put here an AND gate. And then finally, once that we have the output of these two, here the output will be xy, and here the output will be complement of x, complement of y. With these two outputs become the input that enters here, and so the output, when it passes through the OR gate that we have here, is going to be just xy or x complement, y complement. In other words, xy Boolean addition, x complement, y complement.